Welcome to the Explainer. Today we're breaking down a hugely requested topic from a phenomenal source, the System Design Masterclass, specifically focusing on the architect's blueprint. Look, whether you're a seasoned developer or maybe you're gearing up for a massive tech interview, we're taking a deep dive today into how the digital world is built at a truly massive scale. Okay, let's dive into this. Think about this for just a second. Right now, literally as we speak, millions of people are simultaneously streaming Netflix. We're talking about consuming terabytes of data every single second. They're endlessly scrolling through Instagram, firing off millions of messages on WhatsApp. And yet, the apps don't break. Have you ever actually stopped to ask yourself how that's even possible? Dealing with that kind of massive scale without total chaos? It requires a profound level of planning. It doesn't happen by accident. It happens through intentional, absolutely brilliant design. So here is our roadmap for this explainer. First, the invisible architecture. Second, why system design matters. Third, high-level versus low-level design. Fourth, core system components. And finally, number 5, the real-world journey. Starting off with Section 1, the invisible architecture, or the unseen structure. Every single app you use daily, from calling an Uber to asking a question on ChatGPT, heavily relies on this unseen structure. System design is, at its core, the process of defining the architecture, components, and interfaces to satisfy specific requirements. According to our source material, mastering this is quite literally the difference between writing code that works fine on your personal laptop and writing code that scales for the entire globe. Moving right along to Section 2, why system design matters, from scalability to tolerance. Why does this matter so much? Well, the answer really lies in 6 core pillars. First up is scalability. Think of Amazon dynamically adding servers to handle those massive Black Friday spikes without collapsing. Next is reliability, trusting that your YouTube uploads stay safe and sound. Then we have maintainability, which is all about ensuring new engineers can update features without completely breaking the codebase. Performance is crucial too. We expect instant load times because, let's face it, buffering is the absolute enemy. Availability means staying online 24/7. And finally, fault tolerance. If a single server catches fire, the system seamlessly shifts the load so the end user never even notices a hiccup. Section 3, high level versus low level, blueprint versus wiring. Now, what's really interesting about this next slide is how it breaks down these two incredibly important concepts. To separate the planning process, the source material uses this brilliant analogy of building a house. High-level design, or HLD, is your overarching blueprint. You know, the architect's sketch showing the big picture of the whole property. Low-level design, or LLD, well, that gets right into the weeds. The exact electrical wiring, the complex plumbing systems hidden behind the walls. So, translated to software, HLD is picking your overarching databases and servers, while LLD is deciding on the highly specific algorithms and code-level structures within them. Section 4, core system components, modern system basics. Zooming in from that macro blueprint, every modern system basically relies on a specific cast of characters. The client, that's you, making a request from your phone or browser. The server is the brain processing it. Think of the API as the waiter delivering your request to that server. The database is your long-term storage vault, while the cache, that's your short-term memory for instant, lightning-fast retrieval. Then you have the load balancer acting like a traffic cop, literally preventing any single server from getting overloaded. And finally, the CDN, which stores heavy files geographically closer to users for much faster loading. Put it all together, and this is your essential toolkit. Section 5, the real-world journey, putting it together. And this brilliantly illustrates how all these gears turn together. Let's actually see these gears turn together in a fraction of a second. Step 1, you click a YouTube video. Right away, your client makes a request, and a DNS lookup translates the URL into an IP address. Step 2, the load balancer steps in and directs you to an available server for some quick authentication. Step 3, that server checks the cache first, and hey, if it's not there, it digs into the database. Step 4, finally, to deliver that massive video file at lightning speed, the system pulls it from a nearby CDN and playback begins. All of that happens literally in the blink of an eye. Incredible, right? Look, before we wrap up, our source material highlights a really critical pitfall to avoid. A lot of beginners try to memorize a quote-unquote perfect architecture, or they jump straight into low-level coding before they even grasp the high-level blueprint. System design isn't about perfect answers. It's really all about trade-offs. You always have to secure the big picture before you start wiring the house. So the crucial takeaway here is this. The next time you load a web page, take a second to think about the incredible, invisible architecture making it all possible. But wait, how does that very first request actually travel across the world? What really happens in the chaotic, microscopic milliseconds of a simple web request? Well, this is just part one of a 20-part masterclass. Next time, we're going to break down exactly how the internet works, unpacking DNS, HTTP, and the entire request lifecycle. Keep learning, keep questioning, and I will see you in the next explainer.